In this video, we're going to take an amount of liquid. It's just going to be water with some green food coloring in it to make it easier to see. And we're going to watch what happens to its volume when we change the temperature. So the temperature will be changed with a hot plate that will warm up the liquid gradually, and we'll monitor the temperature with a temperature probe. Let's see what happens. So I have here a flask full of colored water. And if we zoom in here close to the top of it, you can see it is completely full. In fact, there's just a little bit poking out of this tube that's stuck through a cork in the top. And also stuck through that same stopper is a temperature probe that I've got hooked up to a lab interface that's hooked up to a laptop. I'm putting two pieces of tape here that are meeting each other right at the top of the liquid level in the tube. And as we back up here, we can see that this flask is on a hot plate. It's a hot plate that has a stirrer. You can see a little magnetic stirring thing, keeping the temperature kind of equalized throughout the flask. And the temperature is displayed on this laptop. And now I'm turning on the heater on this hot plate so the liquid will begin to warm up. And our objective here is to look at what happens to the level of the liquid in the tube as the temperature increases. I'm going to speed this up to about 20 times speed because this is a pretty slow process and you don't want to wait for this whole thing to happen at real time. So my plan is roughly every degree Celsius in temperature, I'm going to move the top tape to the new position of the liquid level. And you can see that it's moving up at a kind of a regular amount every degree. Now I'm backing away to get a better view, so the scale is going to change. So it's a little harder to see if the increments are even, or equal, I should say. And that's probably about as far as it can go. Can the particle theory of matter explain what we just saw happening in this flask in a tall, skinny tube? I think it can. We're going to get some help in trying to understand this from a PhET simulation from the University of Colorado, so we can visualize things that are too small for us to see. It's very handy for this kind of thing. So in this simulation, we have some liquid water, and if you look at the temperature up here, it's 286 kelvins. That's a different temperature scale than we're used to using. So I'll change this to Celsius. 13 degrees Celsius. You see these water particles jiggling around there. They're in constant random motion, as we kind of suspect they are from our last few investigations. This is what water particles we believe look like, these funny little Mickey Mouse type things. But don't worry about their shape right now, that'll come later. Just think about them as individual particles that are moving around. Now watch what happens when I increase the temperature by adding some fire to the bottom of this thing. See the temperature beginning to climb. Take note of how much space the particles occupy and how fast they're moving. We believe that when particles are moving faster, that's what it means for temperature to be higher. So we can expect as I add more energy through heating, the particles are going to move around a little bit more rapidly. Every once in a while you see a particle just kind of leave the liquid and move out into the gas. That's kind of what evaporation is, we think. But most of the liquid stays together, but it's now taking up more space than it used to take up. I'll add more heat, increase the temperature, particles start moving faster, and they begin to take up even more space. As I cool it down, the particles move more slowly, and they occupy less space than they did before. And as I approach the freezing point of water, get closer and closer to the freezing point of water, the particles get closer and closer together. So the particle theory says if these particles are moving, constantly randomly jiggling around, and if moving faster is what happens when the temperature is increasing, then the particles moving around more rapidly, jiggling around with more energy, they're just going to require more space. They won't fit into the same small space that they used to, and so the volume expanded. So the particle theory of matter explains what we saw with the tube in the flask, by thinking about the motion of particles. As those particles are constantly randomly moving around, they need a little bit of space to jiggle around. When we increase the temperature, what we're really doing is we're making that jiggling faster. And since they're now jiggling faster, they're just bouncing around a little bit more and they require a little bit more space. So that's why we saw the liquid level rise in the tube. The particles just need more space when they're jiggling faster, and that's what happens when the temperature increases.